Alright, now we're going to do the law of cosines. So one of the biggest things students have trouble with is when they're given a set of information, they don't know which one to use. Well, here's an obvious thing. You know to use law of cosines when you do not have a complete set, or what I say is the pair, right? So here are your law of cosines. This should look familiar from last year with these three. So the angle that we're given should be the side length on the left side here. Okay, so a squared equals b squared plus c squared minus 2bc cosine alpha. B squared, so it's b, right? A squared plus c squared minus 2ac cosine beta, so on and so forth. Now these three down here, guys, are just rearranging it so that way if you were solving for alpha, beta, or gamma, but really we're gonna go back, so we just have to memorize the format of one and then rearrange it when we need to. Okay, so there's a couple of things we need to remember, because with law of cosines, it's about the order. Okay, guys, you need to remember the order. So let's go over some of our rules here. If we are given a side angle side, so our angles in between the two sides, the first thing we're going to do is find the third side by using the law of cosines. Okay, we know which one to use based on the angle given. So once we do that, then we have that complete set and we're allowed to go back to law of cosines. But this is very important. When you go back to law of cosines, you have two angles now to solve for, and you must solve for the smallest one first. Okay, because if we don't, we run into the ambiguous case. Remember the two triangles. So be careful. Always do the smaller one first. Now, side, 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 no angles. What we need to do is we need to make sure that the triangle exists. So add up the two shorter sides, and the sum must be larger than the third. If it's not, no triangle exists. And the thing is, you want to do that just in case, because otherwise you do all that work for nothing. Okay, so again, it's adding up the two smaller sides and then making sure that it's larger than the third. If we know it exists, then we're going to use the law of cosines. Now, if we're using law of cosines to find an angle, and we need three angles, which one do? We have to do the largest angle first, okay? If you do not do the largest angle first, you could end up with a triangle with the longest side is not across from the biggest angle, so nothing matches appropriately, okay, guys? And now once we do that, we have a complete set and switch to law of sines to finish for the triangle. I would again do it in order then, smaller angle after that, so on and so forth, okay? Alright, so let's go through some practice. Make sure you're labeling what you have. So, solve the triangle where we have beta is 50, A is 7, C is 2, given the exact answers and the decimal approximations, and then sketch the triangle. Of course, remember from last time, the sketching is not as great, but I'm still going to make the triangle so I can see what sides I have. So let's do, if this is side A, so 7, let's say this is side B, this is side C, that means beta is right here, gamma, and alpha, okay? So just like I did with law of sines, I'm going to look at what I have already. So alpha we don't have, beta is 50, gamma we don't have, A is 7, B we don't have, and C is 2. So we have side angle side, no pairs, which means we must solve for the smaller angle or smaller side first. because we need to solve for the smaller angle. So the smaller one is, oh, sorry, here we go. Not law of sines yet. We need to do law of cosines. We're going to solve for that third side. So we're going to solve for b right here. So that means I'm going to use b squared equals a squared plus c squared minus 2 times a times c cosine of our beta, which is 50. Now, when you plug this in the calculator, don't forget that this is b squared. So actually, it might be better just to put in your calculator the square root of all of that. Okay? Which will give us the approximation of 5.92. Okay, so I'm going to put that in there, 5.92. Okay, now we can use the law of sines and go for the smaller angle. And the smaller angle here is going to be our gamma. Okay, so remember, we're solving for gamma, so that goes in on top in our unknown. So sine of gamma all over 2 equals sine of 50 all over our b. Now remember, just to make this correct, we're actually going to put that whole thing in there. Okay, I'm not going to write it in there because it's a lot of writing. Okay, so to solve for gamma, okay, we did this a long time ago. To solve for gamma, it's going to be the inverse sine. Now to get rid of that 2, right, would have been 2 times sine 50 all over that square root. Okay, and now when we do that, we get that gamma is approximately 15.01. 15.01, and that makes sense, guys, right? It's the smallest side, so it must be the smallest angle. And of course, now that we have 2 angles, how do we find the third? We find it by subtracting those 2 from 180, and we get 114.99. Let's make sure. Look, longest side, longest angle, biggest angle. All right, let's try the next one. Okay, in this case, we have side, side, side. Of course, none of my triangles look correct. I'm just sketching them. So 4, 7, 5. Let's see, alpha, we don't know. Beta, we don't know. Gamma, we don't know. A is 4. B is 7, and C is 5. Okay, let's make sure our triangle exists. Remember, we add up the 2 smaller ones, so 4 plus 5 equals 9, and this has to be greater than the largest side, which it is, so we do have a triangle. So remember, with side, 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 we have to find the largest first. So we're solving for beta first, since that's the largest side. Okay. Now, if we're solving for beta, that means that side is on the left side of our equation. So we get 7 squared equals a squared plus c squared minus 2 times a times c cosine beta. Okay, now how do we solve this? Well, guys, we can do this in steps. What I tend to do is put this together and these together so we can see that algebra out. Okay, so of course 7 squared is 49. Then I have 16 plus 25 is 41 minus, well, that would be 40 cosine beta. We cannot put the 41 and the 40 together because it's multiplied by that cosine there, so be careful. Let's do this algebra. How do you get rid of the 41? We subtract it from both sides, so we get 8 equals negative 40 cosine beta. How do you get rid of the negative 40? Well, we divide, so I have 8 over negative 40 equals cosine beta. And then how do you get rid of cosine? That's the inverse cosine, right? So, inverse cosine of 8 over negative 40 equals beta. So let's see what that is. Let's make sure I'm in degree. I am. So inverse cosine of 8 over negative 40 equals, there we go. So beta is approximately 101.54. Awesome. Which makes sense because it's the largest side, so I expect it to be pretty big. And now what we're going to do is change the law of cosines. And we're going to do the smallest angle first. We want to keep in that habit that if we do law of sines, we want to do the smallest one first, which is alpha. So we have sine of alpha over 4 equals sine. Now this time, guys, I'm just going to use the 101.54 because, or I can put this in if I really wanted to, but it's kind of redundant at this point. I'm just going to take my chance and hopefully it's enough for the approximation over 7. Okay, just like we did in the other one, how do you get alpha by itself? Well, the first thing we're going to do is multiply by 4, and then how do you get rid of sine is inverse sine. So we're really looking at that alpha equals the inverse sine of 4 sine 101.54 all over 7. And when we plug that into our calculator, we will get 34.05. And how do we find the third angle? We subtract it from 180, so we get 44.42. That actually does not, let me see. Okay, perfect. Okay, well, let's do some applications with law of cosines. Okay, guys. So here we have a researcher wishes to determine the width of a vernal pond as drawn below. From a point P, he finds the distance of the westernmost point in the pond at 950 feet. So here's point P, and the west part is 950. And well, the distance to the north point of the pond is 1000. Find the angle between the two lines of sight is, if the angle between the two lines of sight right there is 60, find the width of the pond. So what we are looking at, guys, is we are looking for this W right here. So this is side angle side. We can use the law of cosines. The great thing is we only have to do one step because we only need to find that one side, which we can do using law of cosines. So we're finding W, and we have that angle across of W. So we're using W squared equals one side squared plus the other side squared minus 2 times that one side times the other side, and that is a cosine of 60. Now, of course, think about this, guys. When we do this in the calculator, it is not our final answer because it's W squared. So W squared is this 952,500. Sorry, 952,500. Now, if you wanted to do it ahead of time, you could have done the square root just with this. Either way, we should get that the width is approximately 976 feet. Not that bad. Okay, just make sure you're drawing. This is nice because the drawing was made for us, but if it's not drawn out, it helps tremendously on what to solve and what you don't need to look at. Okay, so Heron's formula. So in 7.2, we found the formula for the area of a triangle using Law of Cosines. And now we can do another one, which we have to do in the area using Law of Cosines. So if you remember, one of the Law of Cosines that doesn't work, remember the 1/2 side times side sine of the angle? The idea is we have an angle, but the one we're going to do right now that we have to kind of use the idea of Law of Sines is that there is no angle, so it's side, side, side. Now, here's the idea. Suppose A, B, and C are denoted lengths of the three sides of the triangle. Let S be the semi-perimeter of the triangle. So S is 1/2 A plus B plus C. Then we could actually find that the area is the square root of this. If you want the proof of this, you can get on the internet and watch a YouTube video of how to get to this equation. But so we have tons of area problems now for triangles. We have a right triangle being 1/2 base times height. We have area equals 1/2 side times the sine of the angle in between. And now we have area equals the square root of the semi-perimeter times the semi-perimeter minus the semi-perimeter minus another side, semi-perimeter minus the other side. Whew, that was a lot. So what we're going to do now is actually find the area of our example 2. And if you look back, the example 2 has A equals 4, B equals 7, and C equals 5. So the first thing I need to do is find the semi-perimeter. So the semi-perimeter equals 1/2 times 4 plus 7 plus 5. If we do that out, we get the value of 8. Now I'm going to go straight to my area problem. Area equals the square root. So we have semi-perimeter of 8, 8 minus 4, 8 minus 7, and 8 minus 5. Keep in mind, guys, that the semi-perimeter has to be greater than each of your sides. Otherwise, you would get a negative number in here, and then we can't do the square root of a negative number. When we plug this into our calculator, we get 9.80. And now, of course, this is going to be units squared, but if we were dealing with any other units, remember it's an area. Area is always squared. Isn't this amazing? When we were in elementary, we knew one formula for area of a triangle, and now we have 3. All right, good luck in your practice.